So as we saw previously, if we're given two angles of a triangle and a third side that is either in between them or not, really we know all three angles of the triangle, and so therefore we can solve for the missing pieces using the law of sines. We can find that third angle by knowing that it has to be whatever gets those other two up to 180 degrees, and then we just use our law of sines from there. Well, there is a circumstance where we can be given the information where we know two sides and an angle. That's that SSA case that I had mentioned previously. And so here, for example, we could be given the information, an angle A, 40 degrees. We can see that here. A length A, which is 12, so that's going to be the side across from the angle A, so that's here. And then we're told that angle B is 16. So I've got length B is 16. So I've got angle B here, so then the length is 16 across from it. So this would be a completely valid interpretation of that information. So I've got my 40-degree angle, I've got the side 12 across from it, I've got that length of 16, so I have an acute triangle. Totally reasonable. On the other hand, I could take that exact same information and have drawn that triangle differently. I still have this exact same 40-degree angle. That's no different than what we see in the first picture. This length of 12, if you wanted to break out a ruler, you could see that it is exactly the same length as that other 12 in the other triangle. But now that side is angled inwards towards the triangle rather than outwards. And so then that means that angle B is going to be obtuse, but we can still have a length of 16 across from it. And so all of that information still fits. It's just now that angle B is obtuse instead of acute. That makes angle C much smaller in this second triangle than it was in the original. And so what we have here is what we refer to as the ambiguous case, meaning that ambiguous means it's hard to determine, it's not clear. And so this is a circumstance where if we were just given the information, not drawn a picture, and we had to interpret it, we would have two different ways that we could possibly interpret that information, two different triangles that we would eventually have to solve for. So here's another circumstance that can arise in these side-side angle situations. So here we have angle A is given to us as 40 degrees. Length A across from it is only 4, and you can see that's going to be a problem that I'll explain in just a minute. And then length B is 16. And so we've got two sides and the angle that's not in between them, so it fits that side-side angle model. And this time, I can't close the triangle at all based on the information that's presented to us. It's not possible to create a triangle with this information because that length A is too short. If we drop a perpendicular like we have there for the height, and we want to try to figure out what the height of this triangle is, we can set up a little sine of 40 degrees equation. So sine of 40 degrees would be opposite over hypotenuse, so h over 16. And then if I just multiply both sides by 16, I get that the height of this triangle is equal to 16 times the sine of 40, or b, since this is length b over here, times the sine of angle A, times the sine of the 40-degree angle. Well, if we do that on our calculator, if we do 16 times the sine of 40, we're going to get an answer of 10.3. And so if we have a height that is 10.3, if that height is 10.3, and yet that side across from angle A only has a length of 4, then we have a problem. That length 4, that side A, is not long enough. There is no triangle possible based on the information that's been given to us. And so what we're going to need is some sort of checklist, some sort of way of figuring out if a triangle is possible at all when we're given the information in this SSA format, or if perhaps two triangles are possible, as we saw in the diagrams on the previous slide. So we have to have a mechanism, we have to have a way of being able to tell how many triangles are possible based on the given information. And so what we have kind of going forward in our notes here is a bit of a checklist. So to start off with, in each circumstance, we're going to be given angle A, the length across from it, and length B. So here's our two sides, and there's our angle above it. Again, no bad words in math, so we're not going to spell that out the wrong way. So if we have angle A as an acute angle, so as long as the given angle is acute, right, if A turns out to be less than H, if this side, the length A, is shorter than B times the sine of angle A, then that means we have the circumstance that we see up above, that that length A is just too short, and so there's no triangle that's possible. So we're going to have to calculate what is the height of the triangle based on the given information. And again, that height is always going to be found by calculating B times the sine of A. So whatever the length B is that's given to us times the sine of whatever angle A is given to us. And we'll always be given that information in that format where it's length B, and angle A is the given information. Continuing along, still angle A is acute. So if angle A is acute, there's two scenarios where we can end up with one possible triangle. The first scenario is if it turns out that the length A that's given to us is equal to the height, is equal to B times the sine of A. This is probably our rarest circumstance. We won't see this terribly often where we have the opposite side from the angle that's given to us be exactly the same as the height. But it is a scenario that yields one possible triangle. So once we've identified how many triangles are possible, then we just start using our regular law of sines to solve for those missing sides and missing angles. The other scenario that leads to one possible triangle, if angle A again is acute, and then it turns out that length A that's given to us is longer than length B. If length A is longer than length B, then that's a guarantee that it's going to be long enough to reach the bottom of the triangle, and so that means that there will only be one possible triangle. So we don't even have to calculate the height in that circumstance. We know a triangle is possible. We know that length A is going to be long enough to reach the bottom, and so there's only going to be the one triangle. So again, we can just go straight to our law of sines and start solving for those missing pieces. The third scenario that we have to deal with is when A, the way I kind of describe it, is it falls into the sweet spot. So A is shorter than B, so we can see that here. A is less than B, but after we calculate the height, we see that A is greater than H. A is longer than the height, but it's shorter than B. And so it's in that circumstance where we're going to end up with those two possible triangles. It's what we looked at in the very top part of this section here dealing with the side-side angle. So basically what we have here is the two ways that we could draw the triangle is one where we have length A that's extended out this direction, kind of out away from angle A, and then there's the possibility that I could swing that length inwards, so it swings past the height inwards towards angle A to create an acute angle or an obtuse angle here at B. And so then this is the circumstance where we have the two possible triangles that we have to solve for. The last two circumstances that we have to consider are when angle A, the given angle, is obtuse. If angle A is obtuse, then the two triangle possibility can't happen. So we don't have to concern ourselves with that. But we do have a circumstance where we could end up with no possible triangle, or we could have one possible triangle. And so that depends on the two lengths that are given to us. If angle A is obtuse and length A is shorter than length B in the given information, well then that means that the triangle doesn't work. Because if we recall, the larger the angle in a triangle, the longer the side across from it. Well, if angle A is obtuse, it is automatically going to be the largest angle in our triangle. Well, that means length A needs to be the longest side in our triangle. But if the given information is such that there's a longer side, length B is longer than length A, then there is no triangle that's possible. And then the flip side of that is if we're given angle A is obtuse, but length A is longer than length B, then we have one possible triangle. And so then we just go straight to our regular old law of sines and we solve using the proportions and cross multiplying like we had done in our previous work with the law of sines.